Jack Ames Rupert,
And my name is Torgerud.
and we are presenting about our research on mushroom cushion design and evaluations. Sustainability has been a significant focus in packaging and society in recent years. Companies are feeling pressure to make their processes more sustainable, and part of that process is changing what companies use to package their product. Over 28% of all US garbage is from packaging. The need for an alternative cushion material that is more sustainable is huge, and a potential solution to that problem is mycelium mushrooms. The mycelium mushroom cushion ingredients are hemp hurd and mycelium spores. The hemp hurd acts as a medium for the mycelium to grow around. The mushrooms can be home composted in 45 days. They can easily grow in almost any mold, and it takes around 5 to 7 days to completely grow. They can be dried in room temperature or in the oven, and the best part is there's no special manufacturing equipment required for mushrooms to grow. This provides a low investment cost for the material.
Our research was aimed at seeing if mushroom cushions can meet protective packaging requirements. To examine this, we tested the mushroom's ability to protect the product using the ISTA 1A drop test procedure. This is a test that drops the package from a certain height based on the product's weight. Multiple drops were done with a different orientation being dropped each time to target the corners, edges, and faces of the package. Our process that we use to determine if mushrooms can be a viable option is included designing a mold for our mushrooms. From our previous research, we determined that corner protection is the most important area for cushion materials. Our configuration that we came up with protected that area. Different thicknesses were tested along with other variables to determine what is the best possible way to protect the product. We used an accelerometer which can measure the number of G's that the product endures during a drop. Using this, we can determine what kind of products the mushrooms can protect.
Looking at our results, our aim was to limit the amount of G's that the product receives to under 85. Our first drop was done at 30 inches, in which the mushrooms did not protect the product well as it recorded 100 G's multiple times. Looking at the second graph, we did multiple drops at different heights. 30 inches, 18 inches, and 12 inches were the heights used, and still the product was over 85 G's. Since the mushrooms failed at the heights with different thicknesses, new changes had to be made. The mushrooms when dry were still very stiff and did not provide much cushion, so we tried having the mushrooms be wet. Looking at the third graph, you can see that the mushrooms provided a lot better cushion as most of the drops were below 85 G's. Another strategy that we used was wrapping the mushrooms in corrugate to provide a better cushion and to keep the mushrooms intact after multiple drops. After multiple drops without the corrugate, the mushrooms would tend to crumble. Looking at the middle graph, different flutes were dropped and only a small difference was there. The graph to the right of it compared the direction of the flute, and again only a small difference was noticed. These drops only used corrugate and no mushrooms were used just to compare the difference in flutes and in direction. Looking at the final drop, the ISTA test sequence was used to test the mushrooms. The mushrooms were wet and wrapped with corrugate. They passed the test sequence at 12 inches and at 18 inches.
To conclude, the mushrooms can be used to protect heavier, sturdy products as they are often dropped at a lower height during distribution and are less fragile. Having the mushrooms be wet and wrapped in corrugate is key for decreasing the stiffness of the cushion material. This, however, is impractical as having a wet cushion material with corrugate is not ideal for distribution. The mushrooms also lose their strength as more and more drops occur. This is because they compress and do not return to its original form like normal foam does. The material that mushrooms is likely to replace is EPS, as it is also a stiff material that is used to protect heavier products. Further research and testing should be done to figure out a viable option for more fragile products. Our research concludes that mushroom cushions could be a likely option in the future.